the Lagrange's equation. Let us see the example. Solve x into z square minus y square into p plus y into x square minus z square into q, which is equal to z into y square minus x square. Okay, so this is a Lagrange's type equation. This is very important for the any university or affiliated colleges. This is very important. So let us see how to solve this problem. So this is a given type is Lagrange's equation. What is Lagrange's equation? The Lagrange's equations are P, capital P, small p, Pp+Qq, which is equal to R. Pp+Qq, which is equal to R. In the given equation, you have to write x into z square minus y square into p plus y into x square minus z square into q, which is equal to z into y square minus x square. So here you can see what is you can compare with the Lagrange's equation. What is the capital P? X into z square minus y square. What is the capital Q? Y into x square minus z square. What is the capital R? Which is equal to z into y square minus x square. So now we are going to solve. So the auxiliary or subsidiary equations are, the auxiliary or subsidiary equations are, so the auxiliary equations are dx by capital P, dy by capital Q, dz by capital R. Okay, so now we are going to write dx divided by what is capital P? X into z square minus y square, which is equal to dy divided by y into x square minus z square, which is equal to dz divided by r is z into y square minus x square. So now all these equations, all these are equal. So therefore first you have to find the multipliers. So how to find the multipliers? First I am taking the denominators are in the combination of x, y, z, are in the combination of x, y, z. So that's why I am choosing the multipliers are 1 by x or x, y, z. X, y, z. The multipliers are x, y, z. So in the numerator also you have to, how to choose this multiplier x, y, z? So in the denominator you can multiply with number or variable. You can add or subtract. The denominator must make 0. So my point is I am multiplying by x. So the first term will become x square z square minus x square y square. Second term will become, if you multiply with y square x square. So already first term is having minus y square x square. Automatically it will be 0. So that's why in this manner I am taking x, y, z. So x dx plus y dy plus z dz whole divided by x square z square. First term you have to multiply with x square y square. Second term you have to multiply with y square x square minus y square z square plus z square y square minus z square x square, which is equal to, these three are equal. That's why you can take anything, dx divided by x into z square minus y square. So the denominator, okay, so we made denominator to be 0. You can add this, so you can cancel it. So x dx plus y dy plus z dz divided by 0, which is equal to dx divided by x into z square minus y square. So by cross multiplying you will get, okay, by cross multiplying, you will get which is equal to x dx plus y dy plus z dz is equal to 0. So integrating on both sides, you will get x square by 2 because x dx, if you are integrating x square by 2 plus y dy, if you are integrating y square by 2 plus z dz, if you are integrating z square by 2, which is equal to some constant c. So you have to multiply, right? If you are taking a common in the denominator, x square plus y square plus z square, which is equal to 2c. 2c is also the constant. Already c is there. Again 2c is there. 2c is also constant. 2c is also constant. So you have to take some constant c. So that's why x square plus y square plus z square, which is equal to c1, right? So this is one of the constant. Again you have to take another multiplier. So the next the multipliers are, one multiplier already we have taken. So next two multipliers, second multipliers are 1 by x, 1 by y, 1 by z. You have to choose any multiplier, variable or constant term. If we are multiplying or subtracting, the denominator must make to 0. So if it is 0, what you have chosen, the multipliers are correct. If it is not equal to 0, you have to choose the another multiplier. Okay. So now I am dividing by x. So dx divided by x plus dy divided by y plus dz divided by z, whole divided by. So next x first term z square minus y square divided by x plus y divided by y, x square minus z square plus z divided by z, y square minus x square, which is equal to dx divided by, okay, x into z square minus y square. So the denominator is, you can cancel x by x, y by y, z by z. Remaining terms, if you are adding, the denominator will become 0. So that's why the answer is dx by x plus dy by y plus dz by z divided by 0. So if you are doing the cross multiplication, it will become as 0. So integrating on both sides, you will get dx by x will be log x, dy by y will be log y, dz by z will be log z, which is equal to log c2. So log a plus log b plus log c, that is the formula log ABC. So that's why log x plus log y plus log z can be written as log xyz, which is equal to log c2. So both sides log are having, so you can cancel both sides log. So you will get xyz is equal to c2. Already you got the result of, right, x square plus y square plus z square is equal to c1. Now you have got the result of xyz is equal to c2. So therefore the final answer is, or the general solution is, okay, so the general solution is phi of c1 or f of c1 comma c2 is equal to 0. So phi of, what is the c1? X square plus y square plus z square. What is the c2? xyz, which is equal to 0. This is the final general solution answer. Okay, thank you.